Hello everyone. In today's lecture, we are going to continue our discussion on the topic of plotting. I hope all of you have been able to go through the reading associated with plotting 1 lecture. We have a new custom reading for the plotting 2 lecture. You can find the HTML link and the notebook link as part of the plotting 2 lecture entry on the course website. Let me show you what files are present within the code link. Go ahead and pause the lecture video here and download the template notebook file in order to follow along with the lecture demo. Just like plotting 1 lecture was hands-on, the remaining plotting lectures will also be hands-on. Recall that we wrapped up plotting 1 lecture with a brief discussion on the topic of scatter plot. We are going to continue our discussion on the topic of scatter plot using trees.txt dataset. You don't have to download trees.txt file. The data has already been pasted into the template notebook file for you. For the next example, we'll be doing analysis of iris dataset. You don't have to download this dataset either. We'll be using the request module to directly download the iris dataset from the source website URL. The final example will be about analysis of sp500.csv dataset. Go ahead and download the sp500.csv file. I've already downloaded the template notebook file over here and set things up for my lecture demo. Let me go through the import statements. Those are provided to you as part of the template notebook file. Recall that Pandas integrates with matplotlib just like Pandas integrates with SQLite 3. So I'm going to import Pandas as PD. I'm also importing data frame and series explicitly so that I don't have to keep saying PD dot whenever I want to use that. Next, I'm importing SQLite 3 module, following which I'm importing OS module. I'm also importing matplotlib module so that we can use RC params in order to set specific aspects about plotting. Recall that RC params is like a dictionary, and you can say matplotlib.rc params of a specific setting. During last lecture, we set the font size aspect of plots, and I'm repeating a similar setting for this particular lecture. Recall that pyplot enables you to manipulate subplots within your figure. So that gives us opportunity to create custom functions which enable us to set all the aspects about all of the plots that you will be using as part of this notebook or as part of a particular report that you're trying to write. I've also imported the request module because we'll be using request to download the iris dataset. Let's go through a couple of recap questions about the topic that we covered in the previous plotting lecture. The first question here is asking, how do you plot a bar chart from a Pandas series? Whenever you have a series, you'll have to say series variable name dot plot dot bar in order to plot the bar chart. Whichever plot function you want to use will be used as this last part of your function call over here. The key thing when it comes to plotting is that given a requirement for plotting a specific kind of a chart, I'm quite sure all of you will be able to manage that on your own, even though we haven't covered some of the types of plotting yet. The more challenging question there is, how do you decide what type of plot to produce given a certain data set for analysis? That sort of comes with a lot of practice. That's something which every data scientist is going to get in terms of doing a lot of plots to be able to figure out which plot will work best for the given analysis. Let's go through the next question over here. What are the axes for a bar chart? Recall that when it comes to Pandas series, you pretty much have only 3 things associated with that. You have the actual value, then you have the index, and finally you have the integer position, correct? For the purpose of plotting, only values and index are going to matter. We are not going to be using integer positions. So your index represents the x-axis when it comes to plots generated using series, and the values represent the y-axis. Let's continue our discussion with the topic of scatter plot. Recall that we were using a list of dictionary dataset which represents trees. Each dictionary has 3 key value pairs of age, height, and diameter to represent that particular tree. Presumably, as the age of the tree increases or as the tree grows, the height and the diameter of the tree will also increase. We were able to take this nested data structure of list of dictionaries and convert it into a data frame by just using data frame of trees, where trees is the variable that holds the object for this particular nested data structure. If we take a peek at this data frame, notice that your columns represent each of the characteristics of the trees and each row represents a particular tree. The coolest thing with Pandas data frame is that the structuring of your data set is automatically taken care of by Pandas. So the columns are automatically generated from your data set over here. Recall that in order to generate a scatter plot, we need to explicitly mention what is the x-axis column name and the y-axis column name, or correspondingly what variable do you want to plot on the x-axis and what variable do you want to plot on the y-axis. In this particular example, we plotted age on the x-axis and height on the y-axis. This is pretty natural because it's typical to use the x-axis for any time-based variable. Age is clearly the time representation in this particular data set. And it's also intuitive to use height on the x-axis because as your trees grow taller, your height increases. Let's talk about what are some other aspects of scatter plots that you can control with different variables over here. We already saw that you can control x-axis and y-axis by mentioning what column names or what variables you want to represent in the scatter plot. What else can we do? We can vary the color of the points. We can vary the size of the points. The size of the points are going to be representing diameter of your circles over here. That's a key thing to remember. One of the main reasons for that is a lot of students make mistake in terms of sizing the points when it comes to scatter plots. Since you're dealing with diameter, you always need to make sure that you're scaling it in a proper way. If you were using radius and if you want to represent a unit circle and a 4x circle, it's very easy for you to just scale the column or the variable which represents the size parameter here by just saying 4 into whatever that is, correct? Whereas when you're dealing with diameter, you need to always remember to do a 2x instead of doing a 4x, because if you do a 4x, then you're going to get a circle size which is 8 times the area of the original smaller circle, which is the unit circle, correct? So that's something which you need to be always aware of. The final thing which you can control is shape of the plotting point. So we are just using dot in this particular example. Shapes of plot points include triangle, plus, and many other things which you can define by going through corresponding matplotlib documentation. So let's talk about what exactly scatterplot is enabling us to do over here. Scatterplot is enabling us to compare two different variables associated within our data set, correct? So you're able to plot the relationship between age and the height column in this particular plot. Let's go through the next question here. How do we vary color of the plot points? Let's copy paste this scatter function call over here, and then we can keep modifying it with new parameters. So can you think of how we can represent color when it comes to this particular data set? Which particular variable would be helpful for that is something that you need to always think about. Before we do that, let's just recall the color setting. So we can say color equal to some value. Recall that you can use shortcut name for the color, R for red, for instance, and that will just plot the points in red color over here. You could also use full terms for the color and say RED for red, or you could use a number which enables you to do a grayscale plotting. Let's talk about how to vary the size of the plot points here. I'm just going to show you the parameter for size. You can either say size or you could just say S. Similarly for color, you could either say color or just say C. So let me change the size to 100 over here. That's pretty large when compared to the default size value. All of the parameters have default size values. Feel free to explore what the default values are. Let's talk about the final aspect over here, how to vary shape of plot points. So shape is given by the variable marker. Let me show you how you can produce triangles instead of circles. So this uptick symbol that you get while you press shift and the number 3 on your keyboard will produce triangle. If you want to use circle, which is the default marker, you can just say O, or if you want to use plus, you can just say plus. Again, I'll let you explore the other options for the marker parameter over here. Right, so now that we have learned how to do each of these settings, let's go back to the question of how do we use the additional information in the trees dataset in order to better represent the relationship between age and height variables over here. So I have a question about that. How do we add tree diameter to the scatter plot? So you have three other options for you to go through here, correct? You can either make the diameter size, or you can make it color, or you can make it shape. Are you able to think of which particular representation would be the best to represent diameter? Go ahead and pause the lecture video here and write a comment on the comment section stating which of these options do you think we should use to represent the tree diameter, and the options are size, shape, and color. Alright, if you were thinking size would be the best possible option, then you had the correct answer to my question, because that's very intuitive to represent diameter of a tree, correct? So let's try and see if we can plot size by directly passing the diameter variable as a string into the scatter plot function. So I'm going to say S equal to double quotes diameter, just like I'm saying X equal to age and Y equal to height for the X and Y axis. This didn't used to work before. That's interesting that it's working now. I guess I'll have to improvise my example now. So this did not used to work before. In the latest version of Python and uh, Pandas, I'm assuming they added in support for this. So this does work, and I'll have to go back and fix the note on the completed notebook file for today's lecture. For now, ignore that. Right. What we used to be able to show is that instead of saying S equal to diameter, so we used to say that you'll have to say df of diameter, which explicitly extracts that particular column, both of which produce the same result over here. That's one other way that you can do the plotting. So let me add that into a new cell over here. So you could also say df of diameter instead of just saying diameter. right, the points are really tiny, right? Let's try and fix that. How can we do that? Recall that you can perform element-wise operation very easily on a series, and you get a series whenever you extract a particular data frames column, correct? So you can simply say df.diameter into 25. That will just scale up your diameter variable over here, which is a column in your data set. So let's try and use the scaled up version of the diameter. So I'm going to say df of diameter into 25. Let me fix the double quotation over here. That's so much better for reading the plot when compared to the previous version, correct? Let's talk about how we can use the other two aspects, which are shape of the plot point and color of the plot point. Before I go ahead with the rest of this exploration, I just want to make it quite clear that it is not really recommended for you to use the same column name or a given variable in your data set to represent multiple aspects about your plot over here. So it's not recommended to use same variable to represent multiple aspects of the same plot, but I'm still going to show you how you can represent those other two parameters, which are color and shape, just for the sake of example over here. I'm just going to copy paste this scatter plot function call, and let's say that we want to represent color also using the same column name diameter. Assume that we are not using size over here. I'm going to leave the size as such though, just for the sake of example. So if I say C equal to diameter, notice that you're getting a grayscale representation. It's really cool that you're getting the legend for the grayscale representation directly over here. One thing is that your lowest value, which is 1.0 in this particular diameter scale, is represented using too much of a white scale over here, right? It's really difficult for you to read those particular plot points on your graph. Let me show you how you can fix that. There is another setting called as vmin. I'm going to do that in the next line. Since I'm using parentheses, I can just type enter and keep uh, doing things in the next line. Vmin is going to enable you to set the minimum value for your color scale over here. So I'm going to say df of diameter. So if I just say df of diameter, that will not make any difference at all. You'll get the exact same plot. Right, I am getting some sort of an error here. Let me see if I can debug this. Can only convert an array of size 1 to Python scalar. All right. So I should say diameter df of diameter dot minimum. Sorry, vmin, as the parameter name represents, it takes one value and not like a series of values. So if I say min, there won't be any difference at all between those two plots. What we really want to do is we don't want 1.0 to be in such a white shade of the grayscale color, right? So I'm going to say maybe a -2 there. Let's give that a shot. That's slightly better over here. Notice that your scale now starts at -1. So your 1.0 is sort of gray over here. If you want to make it a little bit better, you can do -3, which will just make the points way more visible. There is one huge disadvantage with respect to using grayscale for this particular plot, correct? The human eye can't really differentiate too much between different shades of gray over here. So you just have to take a call on whether your plot looks good on the grayscale or not before deciding to use grayscale. The advantage of using a grayscale though is that colorblind people can very easily read without any additional help from somebody else or using the colorblind conversion classes. Alright, I'll wrap up this video here. In the next video, we'll go through the iris dataset.